I think we can start now. I hope you can all hear me.
Yes.
Yes, we can.
Okay, great.
Yes,
We'll take our take home from the last class. I'll take a few persons and then we'll move from there. Madam Ngozi, let's take you first.
Sorry, I was not at the last class. This is the first class I'll be joining in, so I wasn't at the last class for some reasons. Thank you.
Okay. Okay. Chimezie, let's take you.
Yes, good evening, everyone. Yes, my takeaway from the last class, which was about quality management. The key elements about the quality of service you render is knowing, what your customer wants, and in knowing what your customer wants, you can adopt best measures and tools and practices in a standard way in achieving, the satisfaction of your customers. And again, we're told that you do not over promise and under deliver. You must always, you must always get it right at all times, as far as FM is concerned. And I think that's a bit of what I could share on the last class.
Okay, thank you very much. You must always promise what you can deliver. It's very key. Francis, are you there? Let's take you.
Yeah, good afternoon, sir.
Good afternoon.
Okay, so my take home was that service quality differs from product quality. That means product is items that you buy, but when you talk about service quality, they are two different things entirely, and you should, in no way, no quality should be below statutory expectation by the law. That means you should not say because your customer wants a latrine, that is what we used to dig a pit hole. You should say, okay, because he wants it, I have to do it for him. No, you have to go according to the building code. That is statutory. We have to always do that.
Insubordination. I will give him free.
Hello? Hello?
Yes, go ahead. I can hear you.
Okay, then that we should bear in mind that quality is not always defined by the service provider, but by the customer, always. We should always know that it is the customer. You have to just know what the customer expects of you. Then you can now define it together with him, try to put things in perspective so that you can give him a professional advice. Then you can now give him that service. Those are my take home from that.
That's good. Very good. Let's take Kingsley. Kingsley, Okwara, please. Your take home.
Hello, yeah, good evening, sir.
Good evening, sir.
Yeah, I think from the last class, what I was able to deduce is that as FM, we should always take into consideration the law of cause and effect. That is, we shouldn't assume customers' expectation, but we should always ensure that we confirm the customer's expectation based on standard and metrics. So I think that is what I was able to do from the last class.
Awesome. That's good. Let's take Yemisi. Oluwa Yemisi, please. Oluwa Yemisi, please. Okay, Yemisi cannot hear us. Awe, please, let's take your take home for last class. Awe, are you on class? How were your take home for last class, please? Okay, Awa is not there. Tosin, are they doing your take home for last class?
Hello, good evening.
Yeah, good evening, sir.
Yeah, my take home for last class, it's promoting quality service delivery and enhancing efficient use of resources by doing things right the first time. You know, paying attention to details, saving costs, save time, and also ensure customer satisfaction at that first time, getting it right the first time.
Getting right the first time, very key
Getting it
at the
right.
journey.
Yeah.
Getting it right the first time is one of the things that as we start this class, I want us to understand as FM. It is a lot cheaper to do it right at the first time. And it's very important for us to have that as our watchword. You know, sometimes we think we will always have a second chance to correct our mistakes when it comes to the works we do. But most often than not, we discover that it is always good to get it right the first time, and it makes the life a lot easier for us. I hope we were able to define what quality was in the last class.
Yes. Know exactly what how to identify what quality actually means. Like saying, okay, quality means healthy balance sheet. It means something you can visualize that this is clean, well-maintained building. Compliance with building, safety, fire codes, and applicable legislation. Those are as in how to identify that quality it's in place.
Okay, great. It's good for us to be able to define quality, which is the totality of the features and character of a product, service that bears on its ability to satisfy given needs. Quality is such that whatever, whether it's a service or a product, it must be satisfied. It must be able to satisfy what it was meant for.
Exactly.
Yes. So if it's not satisfying what it's meant for, it is not time to have met the required quality. So it's very important for us to note that. And even as we continue in our class today, knowing that will help you in your FM career, such that as you begin to interact with several clients, it makes you understand exactly what you are delivering. And once you know exactly what the standards are, it's easy for you to deliver those standards. But most of the times, I hope everybody can hear me. This is by way of introduction so that we'll get into the class. Most of the times, you need to understand that at the inception of any project or anything you are doing, it's no matter how wonderful your relationship with that person is. One thing I always advise in all these classes is that take out time to write things down. Let there be an agreement from the inception. If you have to, you see, some of the things I've been telling you, you will not, some of you would have experienced some things and will have had some bad experiences, and that's not our wish anyway. We want you to be better equipped to be able to manage it as it comes, so that you don't fall into the those issues where it becomes quite messy. But when you write things down, you have agreements, and everybody signs off and there are confirmations. One of the things I've learned as an architect in my career is after meeting with a client to get a requirement, no matter how wonderful the meeting went, I always do an email, or even if it's a text message, or even if it's a WhatsApp communication, confirming our discussion. You know, thank you for the meeting today. This is kindly confirm that this and this and this and these are the things that we discuss, and this is what you want in your building. And I will list everything out. No matter how friendly, I always take my jottings. I will list everything out and ensure that that person sends a confirmatory mail saying, yes, okay, good to go. or add one or two things or that. And most of the times that email has helped me a lot in my career. It has become like almost like a miracle mail, because sometimes the clients normally have selective amnesia, and they seem to forget what they have agreed to when the project is starting. And those kind of emails always help to heal that level of selective amnesia, where the email comes and it tells you exactly what was agreed and you won't be able to deny. That being said, we're going straight into it. We're looking at building fabric and structural maintenance, building fabric and structural maintenance. And we shall be considering the building, the makeup of a building. Actually, that's one of the things we'll be looking today, and how it affects what you do as an FM. Like I said in our previous classes, for you as an FM, you're supposed to really know exactly so much, because most FMs, you manage buildings and then a few services, and it's actually facilities, a facility you're managing, and other things follow. One of the places I worked before, they say to give you a good environment where you can work and play, live, work, and play. That's what's the hallmark of FM. But we must always know that we must work around that. For a building, any building you see that you are managing must have a foundation, must have walls, must have ceilings, must have roof, must have floors, must have windows, and must have doors. These are the basic components of a structure. Basic components of a structure. As in looking at the building physically, these are the basic components. We'll see how this affects. We look at the types of foundations, look at types of wall, types of ceiling, types of floor, types of wall, windows, and also types of doors. Sometimes a good understanding of these things always help you to be able to walk around the structure, and gives you a better understanding on how to manage structure once there are issues in the structure. Building maintenance is essential to prolong the building life cycle and reduce companies' loss. That's is a given. When buildings are neglected, defects can occur which may result in extensive and avoidable damage to the building fabric or structure. It is not only the building that suffers loss, the inheritance of the building are also exposed to great danger. I don't know if you have observed that most of the times, if you for those of you that are not from Lagos, that are probably from outside Lagos, and from time to time you work in Lagos, you live in Lagos, but you are from outside Lagos, and your family house is probably somewhere in the village, and maybe once in a year or at selected times you travel back home, and your building at home is normally left for that period of time till you come. One of the things that you notice when you get back home is that the building, no matter how clean you have cleaned that building, no matter how well you clean the building, when you are traveling, you wash everywhere, sweep everywhere, and clean the whole house, and then you travel. By the time you return in, let's say, 3 months or 6 months time, you will discover that the inside of that building has become dirty, and you will need to clean again. Dust will have settled in, and everywhere will be looking quite dusty. Sometimes for me, I used to wonder, I locked all the windows and all the doors. How come dust enter this place? That's part of the things that you must know in the building. And when you look at the building, from time to when you leave that building, you discover that when you come back, you discover some of the components of the building begin to deteriorate, because you are not there. Not because it was not properly done. It's because when you abandon building for a long time, the building wears out very fast. And that's why if you are building a structure, there must be a cutoff line for you to move into this building, because the longer you leave the building, the more work you will have to still do. The works that you have done before, you have to redo it. Even if you have painted it, after a while the paint will start flaking or chalking or fading out or something. The tiles that you have laid, you do with the best of materials. After a while, some of the tiles you start bouncing out of the wall or bouncing off the floor, you know, and stuff like that. It does happen because of abandonment. So you must note that no matter how bad, no matter how you look at that building, you must try to ensure that you are always maintaining the structure and you're always maintaining the building. Definition of foundation. Foundation is that part of the structure that transmits the load of the building to the soil. There's a part of the building that transmits load to the soil, and that part is called foundation. And every building has a foundation because it has contact with the soil. Apart from buildings that are probably on space that don't have anything to do with gravity, but the ones that we have here on Earth, they always have something to do with the ground. So those buildings, except it's a permanent what's it called, aircraft that's always flying at another lands. But as much as you land and the structure people will live in, you must have a form of foundation, which has contact with the soil and transmit the building load down to the soil. Types of foundation. Broadly, there are 4 types of foundation. We have the strip foundation, which is naturally called the traditional, normally called the traditional kind of foundation. That's the list of the foundation types that occurs. The simplest, when you want to just build a house, you just dig the ground a little, dig foundation, and you set blocks up and you start building. That's strip foundation. Just you dig a strip and put a little bit of light concrete for that, and then you fill it up. You have the part foundation, you have the raft foundation, and you have the pile foundation. For the strip foundation, you normally have the wide, the deep strip, and the normal. There are actually 3. You have the wide, the deep, and the normal. This is the diagram here on your left. Actually the normal strip foundation, while that of the component is the same. The only difference is the thickness of the foundation footing, which is a mass concrete foundation footing. This element here, that is where the block, the foundation wall sits on. And please take note of the components of this diagram. This is called the foundation footing. This vertical one standing here is called the foundation wall. In here is where you have the earth, just called, normally we just say that you have the well rammed or compacted earth. These zigzag lines connote hardcore, hardcore. And then on top of the hardcore, normally we have what we call blinding, the thick layer of sand or stone dust. It's called blinding, on which you now have a first layer of concrete, mass concrete or reinforced concrete, that is very depending on the design by the engineer, what you will call the floor slab or German floor. That's what it is. And then on top of that, you now have the DPC, which is a damp-proof course. Damp-proof course, some people call it DPM, damp-proof membrane. And before you have your screeding, the DPC is supposed to prevent water seepage from the foundation of the structure into the building itself. The DPC actually prevents what we call capillary rise, movement of water from the ground upward into the building. We'll talk about that more when we continue the class. You have the pile foundation. If you look at all those street lights that you see, those concrete stuff you see on those street lights, where the street light stands on, that stuff is called pad. It's pad. That's the cheapest example that I can give you for that. That's pad foundation. And then we have the raft foundation. Raft foundation is normally used where the load-bearing structure of the soil is not very good. It's not very good. It's not very tense. So you prepare something like a table. It's normally done like a table. This picture you are seeing here, I'm sure you have seen this kind of foundation before. If you can see the screen, you understand that properly. I know that I just want to try to expand it so you can see it properly. This kind of foundation, when you see it a lot in several construction sites, is when the load-bearing structure is not too good, and you want the building to be able to distribute the load evenly. That's when you use a raft foundation. Raft foundation is used such that it may balance the load that you require to you carry for the building. And then we have the pile foundation. The pile is when the bearing load capacity of the soil is very bad. And the best way to now manage to build the structure is to build it on piles, where you drill into the ground like borehole and insert from the concrete in to prevent the foundation. Those things are called piles, like what you see. And you drill to where either the bedrock or a more denser part of the soil that will be able to carry and transmit the load of the building. Normally, the depth of the pile is defined by the civil engineers, because they will do their test. They'll check the soil. They'll do all the normal required tests to know the bearing capacity of the soil, and then advise and design the foundation of the building accordingly to be able to carry the building load, the building dead load. Generally, foundation is the any structure that is being built. Foundation, it also determines the kind of foundation. The heavier the building determines the type of foundation to be used. If you are building a skyscraper now, it's not just the height of the building that is the problem. It's the dead load of that structure that would inform a kind of foundation that we use for the building. A bungalow in itself naturally is lighter than let's say, a 5-story building. A 5-story building is heavier than a bungalow that is just one structure because of the dead load. If you compare the number of blocks, the number of concrete that will be on top of each other for the 5-story building, is like carrying 5 bungalows and adding it together. You now say that that 5 bungalow is lighter than the 1 bungalow. That's not possible. The 5-story structure will be heavier and will exert more pressure on the soil than the bungalow. That's why for most bungalow, when the soil is good enough, what you just use is a strip foundation, and then there's no need for you to be going for a raft or pile foundation. But as you are doing maybe a 25-story structure, no matter how good the engineer designs, that building will need to sit on piles, because the load that building is exerting on the soil will be too heavy. Hence, if it's not properly reinforced from the foundation, the building, you may not be able to start the structure at all. Before you get to the finished floor, that building would have collapsed because the foundation is not able to carry its dead load. It's very important for us to note that. Go to walls now. Walls is that part of a structure that defines an area, carries a load, or provides shelter or security for a building. Walls in buildings that forms a fundamental part of the superstructure or separates interior rooms. Now, whatever building you look at, any part of the building that is substructure, the part that is occurring on top that you can see with your eyes, is called the superstructure. Substructure normally for normal buildings can be foundation. You have basement, you can have like 3-floor basement, 4 floors under the ground. Whether it's a basement or not, it's called a substructure. And then anything that occurs on top is called the superstructure. Most walls are part of the transmit the load to the foundation. Bearing walls and non-bearing walls. Load bearing walls can either be internal or external, and non-load bearing walls are walls that do not carry any form of load. They can also be either internal. The internal, what is it called? Internal walls that are done with non-load bearing walls. Other types include parting wall. Parting wall is just is structural unit within a building, just some kind of walls that just divide buildings. It's still not load bearing walls anyway. You also have they normally have good sound insulation. The walls have good sound insulation. Also, serves as a firewall. As a firewall, firewalls are walls that reduce the spread of fire within a structure or within a building or in between building. Firewall normally reduce the spread of fire within a building or around a structure. You also have what we call shell wall. Shell wall is built to stand forces like severe wind or earthquake. Where you have shell walls, especially for areas like beaches or thereabout, or areas or in high hilly or places that are prone to having a lot of a lot of high wind movement. You need shear walls to be able to prevent um, the wind from pulling down the walls of the structure. You have movable partitions, which a lot of us would know. Probably if you are in churches or some other places, maybe in some of these stores, you have some movable partitions, separate or individual rooms, and that's the use, and they are normally not load bearing. We have the curtain walls or facade of building, glass facades. Those curtain walls are normally also kind of what they're normally non-load bearing walls. Types of wall finish. You have the stained glass. Those you can get that in churches or mosques or religious houses or museums or monumental buildings. You have flaking finish. This kind of finish that you can put on the wall in such a manner that it has some waves around it. You also have the marble finish, very attractive. This is when you paste little small marbles on the walls, and it's best suitable for building facade and waterfalls. I suppose those things can come in. You can also use mosaic, just put the mosaic form of paved walls on the mosaic. Cement finish. This is the most regular one that after you finish the block, after you finish plastering, that's use of sand, cement, mortar to finish. You also have the marble finish. That's when you use marble to finish the wall. You have the POP finish. That's when you use POP material to screed the wall. You have tiles, cladding. That's when you use tiles to clad the wall to just make it look beautiful and attractive. Types of materials, types of wall materials. We're just going through these things so that you know them, and of course you would have been seeing them, so you can put names to the things you see and their uses. Plasterboards. Plasterboards are a form of, some instances we call it POP board. They sell it in the market. It's a form of board that is done from hard paper with a little bit of plaster of Paris material that is sandwiching between two papers. It's normally used for partition walls. It is easy to install, and sometimes it's low cost. But for Nigeria here, it's not exactly low cost; it's high cost. You have brick. We know brick. We have the mortar. We know that. We now have the plasters. We also know plasters that are used as types of walls. You have tiles. You use tiles for bathrooms, for kitchens, and all that. You have wooden walls, wooden cladding. Normally, some buildings are cladded, especially if you're talking of offices, executive offices, or lawyers' office. Most lawyers' office are always done with wood because it has a very good sound attenuation. Allows sun moved. You have wallpapers, which are normally used for decoration. External wall, you have the stone cladding. Normally, you have things like that of a wall. Provide protection of any given area. Gives separate spaces in the interiors. Gives strength and stability. Reduces spread of fire from building spaces to another building, and also gives a little bit of thermal control and provides security. Walls actually provide security. It's very important for us to note that walls provide security. If you live in a building where there are no walls and you are sleeping at night, I'm sure you'll be afraid that thieves should just come and carry you out of your building or move your furniture or move everything. So walls give that level of security. Wall maintenance planning. Normally, when you're looking at wall and maintenance, for FM, one of the things you need to do is, first of all, if you take up a building, there's what we call facility audit that you must do for every building that you are managing. Whether it has been done, it is always good for you to do that. If you are just moving into a new facility, always do the facility audit or the building is assessment, facility assessment. You must do that just to let you know the status of the building when you're taking it up. And once you do that, you take a lot of pictures, you know the status of the building when you're taking it over, and you know the things that you are supposed to look out for. Because that will be the starting point for you as the FM personality, to be able to monitor what is going on the structure. Because as you take over the structure, one of the things you must know as a facility manager is that you will be monitoring the building every day. Thorough inspection of walls. It's not just going around the building, you must inspect the walls with your eyes, you look at it. So if there's anything happening, you know. Check for wall movements. There are sometimes that there are wall movements. If you look at it, once you see cracks or spaces in between the wall and the floor, you just take pictures and start observing it and see if there's any movement there, so that in case there's any movement, something that you need to check out for. Check for building settlement. Sometimes buildings settle, so you need to check for it. Correct escape surfaces around the wall. You have flowers and all the grasses that are planted, horticultures that are planted around walls where you work. You need to also ensure they are properly maintained to ensure that they do not affect the look of the wall. Wall maintenance, out of moisture. When the wall receives so much moisture from time to time, by the time the wall is dry enough, the paint of that wall may not be the same. It will begin to flake and become very funny. So normally to maintain that, you scrape out the existing paint and then you repaint. You have the paint, when you have chalking paint on the wall, when you touch the paint on the wall and it stains your hand, it's chalky. This is also as a result of bad weather. And when to do that, to maintain that, you have to scrape out that bad paint and then and replace it. Sometimes chalking paint is also as a result of bad quality of paint. You don't use a good quality paint, some of that thing they just chalk. After you finish painting, you touch. That's why you see some the paint will stain your cloth and also stain your hand or something. So it's a result of either bad paint or weather. Mold growth on the wall. This is caused by leakage. And once there are leakages in the walls, one of the things you must do is that you create a water trap. You first of all stop whatever leakage, whatever the cause of leakage is, look for it, stop it up, and then allow the wall dry. Once you identify the leakage, stop it. After the wall is dry, you scrape it up, and then you repaint such wall. And fixing the corroding. There's sometimes that you also have things like pipe inside the wall, or you have the wall is being affected by salt or corrosive substances or chemicals that will make the wall and the finish of the normally affects reinforcement, also affects galvanized pipes. That's how we do most of the times in buildings, because just corrode, and then the pipe will burst inside the wall and it will start leaking. You need to scrape out the areas that are affected, treat properly, allow to dry out properly, and then before you paint, of course, you would have stop the problem. Ceilings and roof. Types of ceilings. Ceilings are those things that you see above your head in a building, either the soffit or it's or the ceilings. Different types of ceilings. You have the acoustic ceiling. Different ceilings. You have wood stakes. When you have wood stakes that are broken, we normally don't use it in the temperature zone. They're using outside the country, also in the tropical region, they're using temperature regions. You have the metal, which is the aluminum, the zinc, the copper roofs, as it were. Ceiling repairs. Water leakage is a major source for ceiling damage. One of the things you must do is that you identify the source of the leakage and stop it. Once you have a leaking ceiling, you need to identify where the water is. Normally, I always will advise that once there's any form of leakage in a building, one of the first culprits that I will advise that you check is you always first of all check the water sources, whether there is a bathroom there, or a toilet or kitchen, or probably there's a rainwater down pipe or air conditioner drain pipes. Those are things you must check. They are normally the first culprits for building leakages. Please ensure that you check those things first. Don't assume. Once you see the leakages, also very bad ones is the one that comes from electrical conduit pipes. Once that happens, it's always very dangerous, because somehow it will be difficult for you to be able to identify it and then work on it. It's difficult for you to be able to identify it. However, the first things to do is to, first of all, ensure that you stop all the old water sources and watch the place where the leakage is, to be able to find out where the leakage is and get the source of the problem. After you have done that, dry the area above and below the ceiling. Excuse me. Once I've done that, remove the part of the ceiling that is damaged and replace it. Scrape away that part of the ceiling that is bulking, that is bad, that has those stains. Leave the ceiling to allow the ceiling really dry out properly. After you have done that, you sandpaper the ceiling for smoothness, and then you paint. Apply the premier. The premier is the first coat before you do the final painting on those areas. The same still goes for roof. Look at damage is usually as a result of thunderstorm or heavy downpour. When the roofing material is not properly done, that's what happens. Well, you need to assess the roof, check the roof itself, and then check for leakages. Once you have been able to identify the leakage point, you solve that problem. And once you stop that from, you repair it. Once you repair it, if you need to remove and replace the material, remove the damaged material, and also ensure that you stop additional water from going to damage. Floors. We have types of floors. You have the laminate floor. You have the tiles. The tiles has become very, very popular these days. You have the hardwood floor. Hardwood, no longer as popular as it used to be in those days. You have the carpet floor, your rug and carpets that you use. Ceramic tiles, marble tiles are different tiles that you use for flooring. And then floor structure, you have the suspended floor. Most of the times, there you have wooden floors. Most of the times, most of those wooden floors are probably positioned and they're suspended. And also for server rooms in IT areas, they have a lot of suspended floors in those areas to prevent water from gaining access into a lot of the networking cables and the connections, and also to be able to bury the cables under the floor. So the server room is neat enough because they have a lot of cables that are running there. Solid floor, salt base, concrete, the normal regular floor that you have, the German floor is a solid floor. Sorry. And normally screened with cement screen, and before you do the final finishes, in terms of depending on what you want, whether you want tiles, wood, or otherwise. Special floor structures, raised floor, which is normal, like I said, so you can have access to it. You have floors and special balconies area. You treat that with wood and ensure that you manage that. You have glass floor that are made of glass, and the super floor, which are normally in indoor sports area where you have like basketball halls and all that. That's the kind of floors you have there. Floor covering, you have the soft flooring, which is warm but difficult to maintain as a rug, and the carpets. Those ones are very nice, but maintenance is always a problem. It's enough floor that are durable and easy to maintain, rubber or sheets of vinyl, or depending on what you can manage. You have a hard floor that are durable but expensive, concrete. You have ceramic tiles, granite, marble, vitrified tiles, brick, or you have the terrazzo. Terrazzo is not as popular as you normally have in those days. The squeaking floor, squeaking wood floor. Problems with floor. Sometimes if it's not properly installed, you have issues that arise from that. Floor vibrating when tiles are not properly installed. It may cause the floor to vibrate. And once that happens, you know that you need to take out that floor tiles, and then how that issue is on the facility you have. Floorboards having gaps. When you have gaps like this, separate, when you have cracks on floors, you find out if they are structural. Once they are not structural, then you just fill it up and then attend to it. Fill it up with mortar so it cures properly and attend to it. Floor cleaning. Cleaning methods depend on the type of floor. For wooden floor, clean the furniture, you sweep all the loose dust. These are just regular cleaning things. Yeah, I'm sure you already know that. There's drops of cleaning soap, then water, and so forth and so forth. It's something that we are used to, so I won't dwell on that. Cleaning, the mopping and cleaning and using of the materials. You can read that up yourself. I'll just talk about the schedule cleaning, daily cleaning, just to dust and sweep or mop. That's the daily thing you have in your office. Weekly schedule, you do a little bit of vacuum cleaning. Monthly, If the client can afford, you polish the type of floor that you have. Quarterly, you do deep cleaning. That's when you do extensive cleaning quarterly to maintain the structure. Depending on depending on the clients and how you manage and how you want to manage them, you may be able to allow you to do the level of cleaning that is required for the building from time to time. Some persons will not want you to do polishing every month. They'll probably prefer it to be done quarterly or once in a year. But for best results for the finished material, floor finished material, polishing every month is always good. So the floor remains very good, especially if you are talking about granite and marble floor finishes. It's once you do the polishing, it keeps it in very good shape so that the walls do not deteriorate fast around. Windows. Before I go on windows, I want to take a short break so that I can windows and doors is what is left, and then we'll take the schedule of the maintenance. So we'll take a 5 minutes break now. This is 5 p.m. Take a 5 minutes break and then return by 5:05 to continue. I hope that's fine with everyone.
Okay.
That's okay, sir.
Yeah.
That's okay, sir. All right.
Windows. Windows are part of the building that gives fenestration and light, and that brings light and fenestration and ventilation into any given space. There's windows. We have different types of windows. We have the fixed window. Windows are just there to throw in light or just for design purposes. It's not for ventilation. We have the tint and then turn down windows. This is just also the windows that have that are tinted to give a little bit of shade to allow to manage the intensity of light coming into the building, and they are also hinged on the side. Casement windows are the ones that open like a door. They swing out like a door. They are hinged. That's something that you also do. You have the skylights are the ones that comes from the roof that throws light into the space. Window covering, interior window covers. We have the applied when you use film. You just film over the windows and it shades solar or sunlight from coming to the building. Just shade it off. Cellular shades is also in terms of covering. You have the drippers or curtains down where everybody's used to. Interior louvered shutters like micro Venetian blinds or Venetian blinds. Those are the things. That's the way they look. Externally, you have window hood like that, just to protect the windows from the element of weathering, to allow so that you can protect from rain, especially when there's rain, so that you don't have direct heat on the window. And also the exterior roller shades is also to prevent for solar penetration, and also just generally just to protect the window and to ensure that the building is properly protected. Window glazing is just a coat, like a tint, to coat or glaze the glass to ensure that it reduces the light or probably reflects light out, and also helps to decrease solar heat from getting into the building. Depends on how you manage that. Once you glaze, some people use glazed windows for sound attenuation, where you have a vacuum in between two glasses that allows for sound insulation. Reflective coating, that's for reflective glass, reflects the light from coming in and also heat. Gas field, this is also for thermal control, where you have windows that are able to manage the temperature from outside. It does not allow too much heat or too much light from coming in. Window frames, you have the composite frames You also have the vinyl frame material. You have the aluminum is what we are used to. You have fiberglass, depending on the type of frames. You have wood, you have aluminum, and so on and so forth. It's just for us to know the materials I use for windows. For windows window maintenance, use weather strips to remove air and water influence. There's this weather strip that you can also use regularly. So that you can have that properly captured. Window repairs for timber frames. Once there's a rot or decay of the wood or paint, cut off the small parts of area that has rotted, fill with a new one, and then just paint accordingly. If it's a large area, cut off the damaged parts, treat the remaining parts with preventive materials, and then apply primer and undercoat as finishes to prevent more damage from happening. A window sill can be repaired by cutting off the rotting parts and then planting a new piece with of seasoned wood in those areas. Wooden panel. Normally, once you have glazed windows, there's what we call the ceiling cavity, which is the window seal. Some people call it windows or the glazing rubber or glazing seal. Once they are bad, you just take it out and replace with a new one, and the window will be properly firm to ensure that to prevent damp or condensation to happen around them. These are the other things you can read on windows and how to manage them. It's not just regular things I'll need to know about windows. Their maintenance, cleaning the frames, the wire gauze, and all that. You can do that. Deflective lintel, expose the wood to dry and replace bad ones. They're just things I really just know. Let's go to doors. Doors now. There are various types of doors, and that's where we'll stop for doors. There are various types of doors, and that's been used in the building. A door is an access or a barrier which is provided in a wall opening to give an access to inside the room of a building. Internal portions of the door and building are usually connected by doors. Doors normally are classified into four broad types. Types of doors used in building works. The doors are classified into these several types based on one, the placement of the components of the door determines the type of the door. Also, we have the method of construction the door. Method of constructing the door. Working operations of the door. Construction material used for the door. We'll see all that. Placement of component, the way the components are placed will tell the type of doors that it will be. Or the method of construction, the working operation, if it's a sliding door or a revolving door, or the material, you talk about the material, glass door, metal door, all that. They're just simple doors that you just scroll through. You have types of door based on the placement of material. You have the ledge and button. From this diagram, you know what the ledge is. This is the ledge, and these are button doors. These are those old doors we normally have in our villages. We have the ledge, button, and brace doors. Ledge, button, and brace. You have the button, ledge, and frame. Frame round. You also have the ledge, button, brace, and frame. Ledge, brace, button, and frame door. Then typical types of door based on the method of construction. Frame and panel doors. These are the frame and panel doors. You have the glazed doors made of glass. Louver doors. You have the wooden louvers. Flush doors. Of course, we know flush doors just like that. Hollow core and cellular cone flush doors. You see it. These are kind of the wired. That's the kind of door. Types of door based on working operations. The doors are classified on basis of working operations. You know, these are revolving doors, like this one you see in back head office, sliding door, the door slides. You have the double swing, swing door, single swing. You have the collapsible steel door, like that, like so. You have the roller shutters, like so. Roller shutters for stores and for garages. Types of doors based on the material. Mild steel sheet door, corrugated steel sheet door. That's based on the material. Hollow metal door, metal covered plywood door. These ones are like the Israeli kind of doors. And other broad types of doors, you have the French door, you have the aluminum door, and you have the door stopper. Those are components of door. You have the lintel. Lintel is that part of the door on top. The seal is at the bottom. The stopper is what stops the door leaf when it's opening. You have the architraves. Architraves are that part that are faced on the face of the door to make the door look beautiful. The seal is the one at the bottom. The frame and the architraves normally go together. You have for door repairs, these are things that we already know. When the door is not closing properly, you check if the door is swelling due to high humidity. Lift up the door handle. When you are lifting up the door, you are trying to open or close. That means it's rubbing the floor or something, or it's sticky. Check if it works easily, and then check the hinges and all that. Door rubber or sticking on in the frame when the door rubber that is supposed to use to ensure that the door doesn't make noise is bad. It normally happens that it's stuck and causes it not to stuck out. Also, the door not latching properly. Maybe the door has lost alignment due to the plates not sitting well, or somehow you need to adjust the door and check the position. Incoming the door coming in around the door. When the gaps around the door is too wide, and then it allows air, especially for areas of the air conditioned when you need to seal up the space properly. Door maintenance, the flush bolts. Check the flush bolts to ensure that they are properly latching and working well. Services where required, that means you need to oil it. Door frames normally don't have issues apart from the fact that sometimes they can just lose alignment because most of them are made of wood. For those that are made of steel, if you don't have fire or any very high temperature, you don't have a problem. Glass lights in between the door, in case it's cracked, it's just for you to change it. For door maintenance checklist, these are some of the things like that you use for your routine check for the doors. Check the locks and the opening mechanism. Check if the door is operating smoothly. Check if the screws are tight and secured. Check the door hinges and the track for sand or dirt. Check if screws are securely fastened in the screen on the door. The trim off any choking that is loose, seal up the gaps, then check for whether strips is still affecting the door. If the door is still properly in position, or the weather is still affecting the door. When wood is not seasoned properly, after a while, when it dries out, it normally bucks or coughs. So that's why it's always good to allow, especially if you're managing a facility that is a new one and they're supplying doors, You need to ensure that the wood is properly seasoned so that you won't have issues or problems with the door and the door types. Check and ensure that those things are not that bad. Because if the wood is not properly seasoned, after a while it will bulk. And once it bulks, it will lose alignment. It won't be locking well. And I'm sure some of us would have experienced that in our houses or where we work. And when that kind of thing happens, it means that probably we may need to change that door. Okay, I think that's the last slide. So I'll take our questions now and interactions, and then we'll take it off from there. So let's take our questions. If you have any question, then we'll take it. Who am I saying? Anthony, let's take your question quickly.
Hello. Good evening, sir.
Good evening, Anthony. I can't hear you very well. Oh. You need to speak louder. And
can you hear me now?
Yes, I can hear you now.
Good evening, sir.
Good evening, sir.
Okay. Okay, please. Mine is not more like a question. It's more like I want to seek an advice.
Okay.
There is this property I'm managing in Ikoyi. Before I joined the company, the issue has been lingering for years, for over 3 years before I joined them last year.
Okay.
The decking of the ground flat.
The roof deck.
No, the deck,
okay.
Yeah, the roof deck, exactly.
Okay.
The decking, it's a ground flat. We noticed that it's always like it's sweating at every point in time. You know, it will be sweating as if it's sweating maybe, you know, just sweat around all the room. Now, when I came in, the first thing I did was to check for leakages around the toilet, you know. We have to change some of the fittings, you know, the pipe that they use in running, you know, all the hot line and the cold line, we changed. But it still persists. Then I have to go for the AC because one of the ACs, the unit, the outside unit of the AC is placed on the balcony of the upper flat of the master bedroom. So we have to go up and check. We noticed that the AC hose, the water hose, it's like the drain is, you know, blocked. The unit is used to, they use the unit to block the drain. So water was not finding its way out. Exactly. So it's like water was now seeping through the deck into the flats. So what we did was to remove the hose and place it outside. Let's check. After a while, the place dried off. Then recently again, it started again. The thing is more like it's confusing, and we've removed the hose from the recently. Now the thing continue. So my suggestion, my idea was that maybe when it rained, maybe probably water, you know, probably got entered through the balcony. So the openings that is still there that we did not cover very well. Exactly. That's where the water was seeping in before. So I now asked my tiler man to help us, you know, grout it very well, do a very good grouting, you know. So, but we are still watching. But the thing is not like, it's not much like before again, but we are still observing it as it is. But I want to know, is it the AC water that is still causing the problem, or there is another problem somewhere?
Okay, I may not be able to say directly because I have not seen that building you're talking about. From what you have said, sometimes there are different ways these things happen. Like you have mentioned, if you don't have those areas properly sealed up and it rains during rainy seasons like this, you will have that kind of issue, definitely. Your grouting will help, but the grouting needs to be properly done. If the grouting is properly done with the right mix of the cement that you use for grouting, such that not most grout, once it's properly mixed, it's actually waterproof. It will not allow water go through. It will allow it just flow out as it were. But again, sometimes temperature difference causes building to sweat, causes the exchange of hot air and cold air. It's just like condensation. If the upper flat, their AC is very effective and it's always working. It's always working, and that room is always cold. And the one on the down floor is not putting on his AC at all, or is scarcely putting it on. That slab will sweat because of condensation. The transmit of that hot and cold. Normally, the slab underneath on the ground floor will sweat, while on top, because of the coolness that is always there. I hope you understand what I'm saying. It's not just, it will not happen to the slab alone. Sometimes, yes.
Sir, you got it so right. And you hit. Can you hear me, sir?
Okay, I can hear you now.
Hello, sir.
Yes, I can hear you. Go ahead, Tony.
Hello?
Hello, Anthony. I can hear you. Go ahead.
Okay. I said you have hit the nail. Okay, sir. Okay, sir. You have hit the nail on the head. Now, the upper flats, they are constantly using their air condition. They have 1.5 horsepower units. They have a 3 horsepower unit. And they equally have another one.
So that I can't make out what you're saying again. No, that's serious.
Again. Now,
I think it's network.
Tony, your network is bad. I don't know what to do. I can't hear you.
Can you hear me now, sir?
Okay, I can hear you now. Tony.
Okay, what I'm saying is that you've hit the nail on the head, sir. The upper flats they are always using their AC 2-4. Their AC is always on 24 hours. But the ground flats, they don't use their AC at all. But my plumber was telling me that it could be the condensation that is causing the problem. But I was like saying, why, when we removed the hose initially, it stopped. Why coming back again? Do you understand what I said, sir?
I understand what you said. You see, some of these things, it was a mixture of two things that was happening then. As at that time, you had a little bit of leakage going into the wall. So that stopped. It was easy for it to stop because the major source of leakage was attached, was handled. But when you took that out, the condensation takes time. It takes time for it to appear. That the ACs and the functionality has been working for a long time. So it's also beginning to absorb water. You know, so that's what is now showing. If they put up that AC for like a week, you discover that thing will stop.
Hello?
Hello, Tony.
Hello, I'm back.
Okay, I said, is that the problem is the condensation? Is it that the people on the lower floor put on their AC to be able to match up with the temperature they have on top, or you advise the people upstairs to switch off the AC sometimes so that you'll be able to manage that? But if that persists, you may need to get a little bit of like a ceiling, what's it called? POP ceiling over that plaster board. It can with waterproof plaster board, so it will help you to prevent that from coming out, so they won't be seeing it.
I didn't get that. I didn't get that, sir.
I said you can use a waterproof plaster board ceiling over that area.
Okay.
So it prevents that movement because it has a little bit of yes, you can manage that so that you won't be seeing that that sweating anymore.
Okay, sir. All right, sir. Thank you very much.
Chimeze, let me hear you. Your question.
Yes, sir. Just to add to what Mr. Tony asked, I think Mr. Paul also advised that dehumidifiers can also be applied.
Yes.
In such a situation. Yes. And now back to my own question. On site, there's this issue we've been having. Inside of the lift shaft, we usually have water coming down from the floor. And we've tried several measures in trying to plaster everything it keeps.
From the floor?
Down, yes, in the lift shaft.
Okay, yeah.
I know there's this buffer. You know, you must have a buffer that you must not plaster above wherever you're supposed to. So this thing keeps repeating, and it's been a big mess. You know. And secondly, I would like to know what other alternative can one apply in place of felting? I mean, what are the best measures can one apply? In case of felting, it's cheaper means. Because for us, felting,
okay.
Felting is,
okay. Let me just go straight at it. For lift shaft, normally once you make mistake in the construction, it's just like you're also dealing with a swimming pool. Once it's not properly sealed, after a while it will fail, and that's what you're experiencing now. It's difficult to manage, extremely difficult to manage it. And I'm actually handling a construction right now. And when we were preparing the lift shaft, we had to first of all use waterproof cement for all the areas around the lift, and also had to use bituminous felt around it also, and to ensure that we have that double protection. And now, when it rains sometimes and water gains from, because we are not finished the construction, water goes into the roof shaft, it becomes like a swimming pool. The water is not going anywhere except to pump it out. And from where it has gone to show that, the place is watertight, which is good for us. Anyway, that's what it's supposed to be. For that kind of things you have mentioned, is actually a failure of the that tank is leaking. That the roof, the lift shaft is actually leaking. To solve that problem, which is not going to be permanent anyway, you probably will first of all look for a way to screed that whole area with waterproof cement. And after you have done that, you now have to paint with bitumen. Bitumen has a way of helping to prevent water, because normally that is concrete, so it's difficult for you to penetrate that. So you now need to paint with bitumen to a particular level to stop that water from gaining access directly from that area out. And that's the kind of advice I will give for now.
It's all right, sir. It's all right, sir. Yes, sir. And again, for the felting, yes.
Not bituminous felt. I didn't say bituminous felt. Bitumen itself. There's this liquid bitumen that you just use it to paint it, not to felt. You use it to paint it. Vienna, let me take your question.
No, sir, please. Chimeze here, please. Again. So okay, I said I got this, but I asked the second question, like, what other alternative can one apply in place of felt that is possibly cheaper or something?
No. It's not cheaper. No, nothing is cheaper. There's this other material we use. It's called, I think, Rhino Glide. They're also used for such for waterproofing. Also, it's even more expensive than felt. Felt is the cheapest. Did you get that, Chimeze?
Okay, sir.
Yeah, felt is cheaper. Rhino Glide is almost ×5 of what felt, or the cost of felt, but is much better. Okay, Vienna, let's take you.
All right, thank you, sir. Good evening, sir. When you were talking about the designs for the roof type, you said the floor type determine the type of roofing, or is this ceiling? And I want to be sure, how does that play out?
I don't understand. Take that question again.
Okay, you said the floors type, determine the type of ceiling.
Okay. Yes, I mentioned that. In that kind of aspect, normally the quality and the kind of, if you are doing, like, if you have a marble floor now or a granite floor, most of the times the ceiling that you have around there is just cost that you are looking at. Is you probably will do a POP just to match up with it, or sometimes you do something that will be able to match up with the floor finish so that they mix up with that level of detail you have given. You cannot have a a marble floor now and be having slate ceilings over there. It will defeat the essence of having that level of marble on that, that quality of floor finish, matching that kind of ceiling. So that's just the essence of that. That also is part of the things that determines that. I hope that's clear.
Okay, sorry. Then my second question for roofing designs. I am part of a ministry where we are doing an auditorium project, and the roof design is a space.
I can't hear you, Oga.
It's a space frame roof design.
Space frame. Okay, go ahead.
And in my mind, I'm thinking, what are some of the challenges we will have when it comes to we have not yet installed. But in my mind, I'm beginning to think, what are some of the challenges that we may encounter in terms of trying to maintain the roof in the future? So I just said that maybe I can bring that up.
Traditionally, space frame is normally done with steel. Hello?
Yeah, with you.
Okay, great. It's normally done with steel. And one of the things you must do is that, first of all, you need to before the steel is installed, they need to use the anti-rust to ensure that the steel does not rust. Once you do that, once you use the anti-rust paint over the steel before and after it has been installed, that steel can be there for another 50, 100 years and nothing will happen to it. It will be there. And the workmanship of installation is also very important. The parts that they are going to weld the joints is something you need to look out for to ensure that it is properly done and properly coated, so that those areas can also cause a little bit of rust. Once that begins to happen, it weakens the strength of the steel, and it may lead to that the steel frame collapsing. So to avoid all that, you need to manage those small details, and also ensure that the gauge of the design steel is what is supplied to site to be able to carry the load of the roof, so that you don't have that roof failing over time. Because if they don't do that, the load of the roof the roof may sag and it will fall or collapse. We've had experiences where auditorium have had that, and it's not been good. I remember when okay, let me not mention the church now. One big church somewhere in Lupeju, we were walking around there, and they were trying to save costs with the structural designs and all that. And by the time they got the steel and they installed it, it actually collapsed and killed one of the workers. And that was not good at all, because they did not listen to advice. They're looking for the cheaper way out. They now had to even spend more money to now get the specified steel to do it. That same kind of roofing you're talking about. So those are the small things you need to look at. It's minimal, but it's very important for the safety of those that will be in that auditorium, and also for future maintenance. I hope I've answered your question.
Yeah, thank you, sir.
Yes, sir. Okay, Francis, now let's take you.
Hello, sir.
Yeah, Francis. Yeah.
Yeah, good evening. Thanks for the lecture.
Good evening, sir. Yeah, go ahead.
I just want to confirm. I want to confirm the dam protection for the street foundation. Dam protection.
How
is it done? Is it done from Yes. Hello.
Yeah, go ahead.
Hello? Yes, I said, how is it done for the dam protection?
Okay.
For the street foundation. I think that is the only foundation that has dam protection from.
All of them have
from foundation.
Because all of them really have. Anyway, if you go to the market, if you go to a construction market and tell them you want to buy dam-proof course, they will give you it's like a nylon, but it's thick, very thick. I normally use 1,000 gauge. That's the one I've been using for most of my projects because I don't want any issues. Normally, you apply it. There are different ways of applying it. Some persons will prefer to apply it after the German floor has been done. But for me, I normally apply it after the blinding is done before the German floor comes, so that I can have that protection at that level. Then when I'm doing the foundation, the mix of the concrete, I normally sometimes make use of waterproof cement to also give a better effect to stop water rise, capillary rise from going through the foundation. Because if that happens, it's always difficult to maintain. So I always try to prevent that. Those are the two positions I know that normally is used for that. Once that is done, it's just to ensure that it covers the foundation properly. The area you need to cover it properly, and to ensure that that doesn't happen. Also, some people, which I also do, is that the mortar they use to set the blocks from the German floor, they also ensure that that mortar is used. They use waterproof cement for that mortar to ensure that it has also a covering around that the German floor, so it doesn't allow water seepage into the block wall. I hope I've answered your question, Francis.
Yes, sir. Thank you very much.
Okay, great. More questions, please.
Good evening, sir.
Yes, Awe.
Good evening, sir. Can you hear me?
Yeah, good evening. I can hear. Okay, that's Kingsley. Kingsley, good evening. I can hear you.
Kingsley, yes, sir.
Go ahead.
So I appreciate your lecture. It is well enlightened. I just want to ask, when you have a situation where you see dampness as a result of water penetration from the ground, experienced mostly on the ground floor, and you see the wall rise as in swelling up, how do you address? Because if you're, I just want to hear from you. How do you address such a situation?
Okay. You see, this capillary rise is a very, very technical issue. It's very dangerous. You know, very difficult to maintain. Now, normally, what I managed projects that had this issue, and what I did is what I'm going to recommend. There's this chemical they do. Once you identify that has been done, they will break at a level, let's say about 300 mm from the ground or from the floor on the walls. Break it round the building, around every wall, into every room. Break it, and they will insert a chemical into the block. They insert that chemical into the block. I don't know if you are conversant with this baby napkin. It's not diapers. Sorry, there's this. If you know the diapers, I don't know how to. Ladies will know better. Or their pads. There's a chemical inside that diaper that once water gets into it, it absorbs it and does not allow it go through. That same kind of chemical that is being used. It will be sent into that part of the wall and then it will be sealed again. It's such that so that when water comes, I can't remember. I can't remember. I can't remember immediately. I just know that that's it. I can't remember. I'll find out. I'll check my notes and I'll get. I can't remember. But it's not something you usually get from the market. There are experts that does it. You just insert it into it and then plaster back, fill it up. It's such that when water comes in contact with it, it crystallizes. So it doesn't allow the water go through. And when it dries out, it goes back to its form. And after that is done, they now also treat the wall with you first of all scrape out that area, and then sometimes you use bitumen to paint it, and then you'll use waterproof cement to render that area so that water does not penetrate. After you have done that, you use undercoat to paint first before you now put the final paint over it. And for me, that has worked for me For most of the projects, I encountered that, at least for now. At least I know that they have a guarantee that works for minimum of I think 6 years or thereabout, and I think it's been okay. But it's a very difficult. If it is not what I've just described now, if it's also not properly done, it will not work. It will fail. So it needs to be done meticulously, and it can be messy anyway. So that's what we probably will get. But like is often said, prevention is better than cure. I'll prefer that we really prevent that from happening instead of getting to that problem. But as facility managers, you are the receiving end, so you always be the one to suffer the problem after the building has been constructed. I think that will work. I'll probably get the chemical and probably send to us on our group.
Thank you very much.
Yes, please. I've been seeing Tosin in your hand and I can't see you anymore. Tosin, are you still there? Your question?
Yes, I'm here. It's just a very short one. It's
okay, go
about
ahead.
The wall. How do you know when the wall settles?
When the wall settles?
Yes.
Okay, I want to presume that you are talking about foundation, because the wall does not exactly settle. It's the foundation that settles, or the building generally that settles. Ideally, building settles between 2 to 3 months after it's been constructed. So you really do not notice it, except you have two different structures. And that's especially for people that do renovations and expansion, that's where they always find this problem of building settlement, because the building settles differentially. And when you are adding a new part of a building to an old structure, it's always advisable to put an expansion joint in between the 2 points. So that when the building is settling, you don't have cracks. The building settles separately, and then it flows normally. Once it settles. Normally, during construction, you try and ensure that the new one is a little bit higher than the old one, but you will not know, except you are very critical. It's only people that are doing the construction that know exactly what they are doing. You just make it higher above the old one, so by the time it's settling, it settles down to meet up with the new one. With the old one. So, and there's always an expansion done, it's properly done, so it doesn't you don't have crack in the building. I hope I've answered your question.
Yes. How about when you now have the cracks on the wall? How is the best way to handle that?
Okay. For building cracks, there are majorly two types of cracks. You have the surface crack and the structural crack. Surface crack may occur when you use poor plaster sand for the plastering or the finish or the rendering of the wall. After a while, if that mortar absorbs water and dries out, it's after a while it will start cracking. That is easy. You can just tap that out and replaster. But if it's a structural crack, it will come from the foundation. That's the most dangerous one. Whoa. And once it comes from the foundation, you will see the building tilting. You just need to observe. If it's building settlement, after like 2-3 months, it will stop. It will just expand and to stop. If it's that one, then you don't have too much of a fear. You just fill it up, fill up the area with concrete. There's what we call bonding agent. You mix it up with you mix it up with the cement. You pour it in before you now fill up with cement with the sand cement screed, so it holds the two elements together properly. Once you do that, that'll be fine.
Okay. All right.
But if it is not that one, if it is failure, when the building is failing, there is nothing you can do. You may need to bring down the structure and reconstruct.
Okay. Thank you very much.
Yes, please. I think Awe, your hand is up.
Good afternoon, sir.
Yeah, good afternoon.
Yes, sir. Thanks for the lectures. I really appreciate it. And my first question is on rafter foundation.
Raft foundation. Yeah, go ahead.
Yes, raft foundation. Yes, I can see with the image you added to the slide, you can see something like a framing also. But my question is, what if that particular soil is not really that hard? It can carry some weight. How is there any advice or any approach that the digging of the foundation before casting and putting reinforcement must be there. It must be to an exact depth. Do you understand my question, sir? Like,
I
I'm
understand your
trying to.
question.
Yeah. Okay. Since you understand the question, so
I
I want to know
understand.
that is there any specific depth before you can dig before you can use downward particular foundation?
Okay, great.
Okay.
Especially in what? Tell me.
Especially in maybe in like a damp area or somewhere
Okay.
where
Okay, I know. I just want to be sure that that's what you're saying. Anyway, for raft foundation, all types of all foundation types, one of the things that you must do, which I mentioned, but I mentioned it silently or personally, is also important, is before you start any construction, you must do a soil test. That soil test that is what engineers will use to determine the type of foundation based on the load that is coming on it. If the engineer determines, oh, we can do a raft foundation here, that is what you will have to do. The depth of that raft foundation is also determined by the engineer, by also that soil test that you do. It's not by you just wake up one day and say, oh, I'll do my raft foundation to 600 mm or 1.2 mm or 1.8. You can't do more than 1.8 because I've done a raft foundation that is 2.4 meter deep.
Wow.
Because of the soil test. Ideally, before you start your construction, you're supposed to grub out the first soil layer and take it out, the humus soil, and then you fill back. That's what normally they call it import sand. You import sand into the site. You grub out the bad sand, and then you fill. Whether if it's a swampy area, you fill that swampy area. You clear it out. You fill that swampy area first before you start commencing your construction work. But most people don't do that. They just go into the place and put wood there and start pouring concrete into the thing, and water will be entering the concrete and all that, doing all this kind of rubbish construction. At the end of the day, the ground foundation will fail and the building will start sinking. They'll be acting like it's the devil. It's not
Exactly.
devil. It's bad or it's bad workmanship. When you're supposed to have filled that place first, do your soil test to give you that. The particular thing that you're supposed to do. And once it gives you that, once you put your structure on it, it will stay. But if you don't go through that process, you will think you have done raft foundation. After a while, you see the building tilting to one side, sinking at one side. And of course, once that begins to happen, you know that they also will come and mark the building not fit for rehabilitation. That means it's going to go down.
Okay, I understand. Then my second question is, in some libraries, when you check the ceiling, it has some holes, but the hole is not linking to the other end. But you can see it's not regular. Some place there will be like a cycle that goes inside, like
I understand what you're saying. Those are acoustic ceilings anyway. It's for ceilings that it's just a ceiling type. It's a pattern. It's like a design on the ceiling. But
okay, I used to think it's serving like maybe because of noise or so that the noise.
Yeah, the acoustic ceilings anyway. If you look at it's not that those holes does not, it's the material that is actually acoustic. That things you are saying that is just a design, but the material itself is what is acoustic, because normally as it were, it's like I said, it's acoustic. It's just to prevent sound. Really, it also helps to manage the sound at each floor, so I don't have a reverberating sound or echo within the space.
Okay. Then my last question is,
please go ahead.
Yes, the question is something like a practical. So I just want you to talk from your experience, because now we have we have families that are building house, and we'll be like, we want you to come now. You say you are into facilities. Come on, let me just stay with these people at the site. Some kind of situation like that. Let's say, for example, now they started from foundation, like the blinding, like how many hours or like how many days should we wait before putting on bricks on the cladding? Then when after molding.
No, sorry, go back. Take what you have said again. I don't understand what you have said. How many days do you wait for what?
For blinding, the foundation blinding. Like how many days will you wait for it to heal, or for it to be able to bear the weight of the bricks that are coming on top? Then the lintel as well. How many days will the block be set before you can apply lintel? Then roofing. How many days will the structure be before you can start putting a rafter on it?
Okay, let me start from the first one. You talked about blinding. blinding is not the structural element. You don't need to wait for how many days for blinding. Blinding, once you put blinding, now you can start putting your thing on top. What is critical is the infill, the sand that you are infilling in the laterite that you are bringing into that space. That's the one that you need to ram properly, ram and compact well. Normally you use water and use machine, use a plate compactor to compact it so that the soil is firm enough to be able to carry the German flow that is coming on it. After you have done that, that's when you now put your hardcore. Hardcore are very heavy, big stones, bullets that you put on. Yeah, once that is done, your blending, once you put your blending on your hardcore, as you are putting the blending, you can even cast immediately. It doesn't matter. It's not serving any purpose. The main thing is the hardcore and the compact earth. So that's for that. For lintel is a concrete element. Ideally, but lintel is not carrying much load. So lintel, once you cast a lintel, in like 5 days, you can continue your block wall. That's not a problem. For the roof beam is also the same thing. After 5 days, you can do that. But for slab and columns, for slab, you have to wait for 28 days for it to attain its full strength before you can load the building. I hope I've answered your questions.
You did. Thanks so much.
Correct. Any other question?
Yes, sir.
Okay, Tony. Tosin, go ahead.
Yes, I just thought about this. How do you do your septic tank or soak away in a waterlogged area?
Okay,
see water almost. It's easy to do foundations, but for a septic tank or soak away, how do I go about that in a waterlogged area?
Okay, commonly what they do is actually a building technique that they use. They actually do it on the surface and then sink it. The soakaway is built on the surface. They build it up and you'll be seeing it high.
Okay.
And they now sink it. How they sink it, that they go in and start digging underneath and dig.
Okay.
Until it sinks to the point where they require it. It gets to that particular level. And then they close up the bottom and it's done. Normally at the jointing between the floor and the wall, there's what we call water bar. The water bar is placed in such a manner that it prevents water from going through the jointing areas for where you have the concrete, so that you can have the place properly, the septic tank properly sealed. Apart from that, that's what we normally do anyway, except you want to do a precast septic tank where you just also dig the point and just use your crane to drop it in. Those are the two ways you do it.
Okay, so thank you very much.
Yes. Tony, your hand is still up. Do you have another question?
Yes, sir. Hello, sir.
Please go ahead.
Okay, sir.
Yes, Tony, your hand is up.
I want to ask, yes,
Okay, go
sir.
ahead,
I want to
question.
ask, sir. I want to find
Yes,
out. If you have a crack, a new building, then the crack, from outside, you can still see the impact from the inside. Is that really a settlement? I just want to find out, sir.
It depends.
And what is the?
Okay. It depends.
Hello, sir.
Yes. Okay, go ahead. Finish up with your question.
Okay, then I want to now find out what correction can be done, to stop that, or what correction can be done, after the settlement. What can be done to, to guide against this again, sir?
Okay. Quickly, where it is building settlement, that crack will come from the foundation. You see it going on. If you're having a 5-story building, that crack will come all the way from on top down to the bottom, to the foundation. And once you watch it, it takes time. Once you watch it, you need to take out time to watch the crack. Sometimes you take measurements, you take a ruler or a tape to see how the thing is expanding. You watch it for like a month, between a month to 3 months. And if it continues after 3 months, then there's a big problem, like I've said earlier on. But if it's settlement, it will definitely stop after 3 months. It will start, expansion will stop. Maybe it stops. You notice that it has stopped. You just use bonding agents and mix it with the mortar that you're going to use to fill it up. Just like you're replastering, just to fill up that space and fill it up all the way. And after a while, you won't see it again as much as building has settled. But if it's not building, if it's not, if like I said, yes. So once you do that, it will solve the problem. Let me see. Let me take your hand.
Yes, sir. Thank you, sir.
Yes, madam.
In respect of what Mr. Antonio so just asked now, the crack
Yes.
in the wall. That was a project that we are doing right now in the office. So there is crack, and that place is 2-story building. My boss now said we should put pillar we should put pillars on those areas. I didn't know how that one will work with what you taught us this evening.
Okay. You see, like I mentioned,
the pillar, the crack. They said the crack came from. Comes from the
foundation.
roof. That's what they said. I don't know.
Wait now, calm down.
And we are seeing it from the first floor. Yes, sir.
Wait, listen. You have not. I'm sure you have not been listening to what I've been saying since.
I listened. I was silent.
I said, if that crack, you need to monitor the crack. Yes, you need to monitor the crack first.
Yes.
Monitor it. You don't just wake up and go and be putting in column. What are you putting column for? If you put column there, what's the column doing? You need to monitor the crack first to know exactly what that crack is. If the crack is due to building settlement, it will stop. And once it stops, the building has settled. If the crack is structural, if the foundation has failed, that even if you put column there, the building will still fall. So I said, if it's a structural crack and it's a foundation failure, there is nothing you can do. You have to break down that structure and redo it again, except you do what we call underpinning. Underpinning is when you go and build another foundation under the existing foundation. That one is very expensive. You almost like suspend the existing building. But if the foundation that you have done before is not good before, you cannot even suspend, you cannot do underpinning if the foundation that was done there is bad. So the building will fall. So there's nothing you can do. Even if you put a column, it will still fall because the column will sit on the foundation. So this is to ensure that, oh, this thing is if it's is expansion done, you have seen, okay, no problem. Is what's it called? Is the settlement? The building is settling, okay, no problem. If you put column when the building is settling, no problem, it's fine. It will help the building just stay. But even the column you are putting, it will also settle.
Okay. Thank you, sir.
Yes. You know, some of these questions you guys are asking, I have not seen the pictures. I'll be able to give you better answers when I'm seeing pictures or I'm there to look at it. I cannot tell, okay, this is a solution based on my experience and what I've done. But generally, these are the things that you look out for and it will help you to manage these things as they come. Tosin, your hands is still up. This type of question.
No, sir.
Okay, great. I'll take more questions. Do you have more questions? Any other person? Please, so let's ask. So that's why I normally would kind of try to rush the class so that I'll be able to answer your questions, because once you ask some of these questions, you'll benefit from my answer, and you may actually be talking about somebody else's problem that we are solving, and that's the essence of the class. It's not just for you to just come and attend class and go and read your material, and you cannot apply these things to what you are seeing day to day. So far, I like the questions I'm hearing, but I want more. If you don't have, then that's fine. Okay, Vienna.
That's okay.
Go ahead.
Okay. Okay. I was going on an facility inspection with
Yes.
our facility project engineer, and I showed him something and he made a statement which I thought I would have time to research. We noticed in one of our fuel dump that the tank came out of the ground on its own. And so when I pointed it to him, he said it's soil buoyancy. And I was like, how does that play in that area? What could be the cause? Because apart from there, there's also one other place in our plant where we also have that kind of similar occurrence where a concrete structure also came out, almost like coming out of the ground too.
Yeah. Okay. You see, some of these things. Have you ever heard of what they call landslide before?
Yes.
Okay. Sometimes it happens faintly. If around that area you find that tank, around the area, the soil there is water penetration and it's leaking out somewhere. That soil is escaping somewhere out. It creates a void. And once it creates the void, that's what you call that soil buoyancy. It has lost the grip that that thing has around it. That's why you see it coming out. I don't know if you understand.
Yeah, I do.
Yes, it's a natural occurrence. It's not anything they have done wrong. It has just happened by itself. It's just because probably the whole perimeter of where that tank is was not, there's an escape somewhere. That's why it's always good. Normally, once you are doing things like a filling station or you're working in an where you do a lot of underground water works or these things, normally you encase that tank in a concrete tank before you drop the tank inside. And then you also fit there's this clip you use to clip the tank to the bottom to ensure that the tank is fitted well. So that if that happens, it doesn't affect the tank directly in its contents. It's just the box, the concrete box will still be secured and everything inside there will be safe. So it's just the environment around that has the issue. So you can just always refill with sand and run properly, look for where the escape route is, stop it, and then you surface it and everything will be fine. I hope I've answered your question, sir.
Okay, yes, but in the two scenario, one of them is a fuel tank, I think AGO tank. Then in the other case is a concrete structure, almost like the concrete box you described, that also came out of the soil, out of the ground.
Yeah, like I said, what you should be really off, if the concrete box is still intact, you have done a good job with that.
Yeah, the structure is intact.
Yeah, that's what I'm saying. I said the problem now is not the environment, the things happening around that box. It's the sand that is losing, it's failing. So what you now have to do is that you excavate all those things around that side, refill back and resurface. I don't know if you understand.
I do.
Yes, you excavate, look for where the problem is, because the problem is not too far from that. Once you excavate, you will see it. You will see the sand. You will see where the sand is escaping from. If you take a critical look, go around, you will see it. Once you see it, you stop that point where it's leaking out. Then fill back and compact properly. Sometimes, if you don't do that compacting well, this is what happens. It creates air void in between the soil underneath. And after a while, once it rains and water gets to the ground, it will cause things like this to happen because the soil will settle. And once it settles, you create that void. And once that void happens, this kind of thing happens, it will just pop up. So if those things are not properly managed, these are the results that you may have. I hope I'm clear.
All right, thank you, sir.
Yes, sir.
Sir.
Yes,
thank
Tosin,
you so
go ahead.
much. This is Tosin.
Yes, go ahead.
I want to know, I asked the possibility for or the effect of drilling to the integrity of the wall. For example, it's like an 8-story building. It's an hotel, 471 rooms that was designed to use a central cooling system. That's a chiller. Yeah. So now introducing AC for each of the rooms. That means like having 471 ACs to the 8th floor. The drilling of the I'm looking at the possibility. How viable, how possible could that be?
Well, like I had mentioned, I think I mentioned in one of our class that would not be a good advice to be doing split units for that kind of structure. it's not going to be cost effective, except you have balconies at every room where they can sit the condensers for servicing. If not, it will be we are going to take they are taking a dangerous business decision, because by the time each of those ACs require servicing and you need to service the condensers, how do you service it? It will be more expensive to service than to buy an AC. So that means you just be changing AC every time. Anyway, that's on the wayside. But drilling, depending on the structure, if the structure is stable enough and they are not drilling into any of the structural elements, you are fine. You're not touching the beams, you're not touching the columns, you're only drilling walls, and that's fine. But if you are touching the beams and their columns, you are compromising the integrity of that structure. And over a period of time, it's very possible that that building may begin to experience cracks that may cause it to collapse. So we strongly advise against drilling beams, drilling columns, because it's going to compromise the structural stability of that structure, and it's going to be a big problem. Yes, sir.
All right, thank you, sir. So it is best that if it has balcony for positioning of the outdoors.
Well, you can use, yes, you can use if the building has balconies at every level that you can put your the condensers. Yes, you can go ahead and do that. But if it doesn't have, I would advise that they invest in going, instead of doing the chiller system, they can use what there are new technology called VARV or VRF, which is cheaper than the chiller systems. That in itself, it will serve better. You can easily also maintain, because the condensers will be probably at the central point, maybe on the top of the building, and then it services all the floor. You just do the piping down to all the floors, and it will be fine. You go through the ducts. You just still go through the ducts that the chiller system uses, and then you'll be able to manage it. I think that will be a better option than going through the use of this split unit, the split unit AC. That the VRF or VRV system will be much better and easy to maintain. Because split unit for high rise, I don't always advise it. It's terrible. Even the hair handling units at the back, at the high point where you begin to have, I hope you know that the higher you go, the increase in air pressure may also damage the split unit itself. So it make it not effective enough. So why do you want to go through that stress?
Thank you, sir.
Yes, sir. Any more questions? Okay, if there are no more questions, I want to say I hope with these few points of mine, you have been able to learn something from this class today. I want to thank you for attending class. We'll see. I think I still have one more course to take you guys. I'll look at that on the date. We'll discuss more. Please, if you have more questions, feel free to always ask. I'll be on ground to answer your questions as it comes. At least by God's grace, God has helped us to gather small experience to be able to answer your questions. I know some of you are shocked that some of the things that happen to underground tank and all that, how will an architect be able to answer it? It's because of my experience and the work I've done over the years. We've been able to have faced some of these challenges, so we know what happened in the variety of structures. So if we don't have any more questions, we want to call it a day now, and then wait for the next class. Thank you for attending class, and God bless you.
Thank you very much.
Sir.
Yes, sir.
Thank you very much, sir.
Thank you very much, sir.
Thank you, brother.
Thank you, sir.
Thank you, Fmmc.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you very much, sir.
Thank you.
Thank you, sir. By next class, we want to see your video. It should be a video class, not another
Okay,
class.
no problem. All right, no problem.
Thank you.
Don't worry, even during your graduation, I should be around, so I'll be able to see you guys the same.
That would be